Here, if y'all still need some of those answers, there they are. All right, somebody said 2. All right, now before I get started, let me get these up here. All right, here's my first one. Now, let's divide through by cosine squared. So that's going to give me tangent squared, right, plus 1 equals secant squared. All right, now let's divide through by cosine squared. That's what we just did. Never mind. Let's divide by sine squared. So they give me 1 plus cotangent squared equals cosecant squared. And might need that later. All right, number 2. You had secant squared x minus 1 over sine squared. Now, let's look. We got secant squared minus 1. Could we make that into something? Yeah, that would be tangent squared, right? Tell me if I need an explanation for you there. Secant squared minus 1 would be tangent squared. Now, what about from there, though? All right, just change everything to sine and cosine and see what we can do with that, okay? So tangent squared we can write as sine squared over cosine squared over sine squared. All right, now we've turned it into a complex fraction, so we got a complex fraction. Instead of thinking of it as division, let's multiply by the reciprocal. Okay, so sine squared x over cosine squared x. Now, we're going to multiply it by the reciprocal of our denominator there. What's just the reciprocal of sine squared? 1 over sine squared. Okay, now that'll cancel out. That turns out real nice. So you get 1 over cosine squared. All right, but what's 1 over cosine squared? Secant squared. All right. That's okay. That's okay. I'll let that go. Sure. All right. All right. I'll try to go in order. Let me start. Now, let me just do this with 10. Let me just explain. Look at it, everybody. Sine squared plus cosine squared in the numerator is just 1, right? So you get 1 over sine squared, which is cosecant squared. Is that okay now for number 10? Okay. All right. The other one, y'all, somebody said 14. Okay, you want to do 16. 6. Okay. All right, we got 1 minus sine squared theta times cotangent squared theta plus 1. Now, because you got ones and squares here, it's really not going to be a good idea to try to like fall that out. That really wouldn't work out too good. But let's look. 1 minus sine squared, what could I put for that? Cosine squared. Okay. All right. What about now cotangent squared plus 1 is cosecant squared. Now, that got rid of those ones, and those two don't really go together. Now, they're multiplying, so let's think when we multiply, what really starts working. Right, just change everything to sine and cosine. So we get cosine squared theta times 1 over sine squared theta. Nothing's going to cancel out. That's just going to leave me with cosine squared theta over sine squared theta, which is cotangent squared. All right, is that okay? All right. All right. All right. Now, let's see if we can spot us a Pythagorean identity in there somewhere. How about that secant squared minus tangent squared? Not quite. Maybe just one. All right, let's look at it. All right, we're going to take tangent squared and subtract it over, right? And that will give me secant squared minus tangent squared. And so, right, what's left on the left side is just 1. So now we got 1 minus sine squared, and 1 minus sine squared would just be cosine squared. All right, 16. Now there's no squares in those, so there's no Pythagorean identity that's popping out yet. All right, so I don't know. If we don't know anything to do, how about we just do what we normally do in algebra with parentheses? What's that? Yeah, just distribute. Okay. All right. So we get sine x times cosecant x minus what would sine squared x. Okay. Now, what are we sort of missing that we need to go with that? All right, another squared one or a 1, right? Now, anybody see where I could get something like that? That's going to give me 1 because I can change, all right, cosecant to 1 over sine. So now those will go away. So you got 1 minus sine squared. Now you got your 1 and your sine squared. So that's just going to give you cosine squared. Okay. All right, what else now? Just say 16. Oh, that was 16. 18, okay. All right, I'm going to talk you through 18. All right, it was real similar to number 10. All right. In the numerator, sine squared plus cosine squared is just 1, right? So you got 1 over secant squared. Now that's a reciprocal identity, right? 1 over secant is what? It's just cosine. So it wouldn't be just cosine, but yeah, it would be cosine squared. All right, talk to me. Was that okay? All right. All right, 20. Now 20 was the one I kind of told you about. Sure didn't upload that. With number 21 yesterday when we worked it out. I had cotangent squared x times tangent squared x plus cotangent squared x. So what did I tell you about having two terms the same like that? Yeah, factor it out. Okay, so we'll factor out a cotangent squared, and that's going to leave me with tangent squared plus 1. Now, I bet we can do something for that right there. Yeah, I think you're right. Let me see. Yeah, tangent squared plus 1 is secant squared. All right, I just factored out a cotangent squared. Okay, did you get the factoring part okay? All right, and now tangent squared plus 1 is secant squared. So now I'll get cotangent squared times secant squared. All right, but now what? Right, change everything to sine and cosine. This would be cosine squared x over sine squared x. Secant would be 1 over cosine squared x. So those will cancel. So let's skip a step here. That's going to give me 1 over sine squared. That's just cosecant squared. All right, what else? All right, now, I really wanted to go on to the next page that I gave you in that packet, which was trig expressions 3. Now, I'm going to tell you this. Hold on to it, okay? We may get to it later on, but not today. If anything that we don't get done, it'll be trig expressions 3. And the reason is the stuff that we have to do for the rest of the year is a little more important, okay? So hold on to it. Now, that review, we won't get to it, okay? So, I mean, just, you don't have to tear it off, but we're not going to get to the review part on that. All right, we got to move on to the solving trig equations. Now, let's look at those, the solving trig equations part. And let me go ahead and tell you before I actually start what the homework is, since I didn't write it up, okay? All right, let's see which worksheet that the solving trig equations. You're going to do 11 through 23 odd. Just circle that whole little column right there. And then 85 through 90. All of them, yeah. All of them on those. Okay. Now, 11 through 23, you're going to do really, really well. Okay. I'm not really worried about you there. Okay. But the other ones there, 85 through 90, I think you're really going to struggle. So we need to kind of rush up to get to some examples like that. Now, let's start off is how do we solve a trig equation? All right. The idea when you solve a trig equation, first thing you want to isolate your trig function. So isolate sine x, cosine x, tangent x. Just get it by itself. Okay? And then for the most part, what you're going to do is just use your unit circle. Okay? Now, notice when it says in exercises 11 through 24, find all solutions. Okay? And on 25 through 38, it doesn't say all solutions. What kind of read through that? What does it say on 25 through 38? All right, solve each equation on the interval from 0 to 2 pi. Okay, so on 25 to 38, you're only finding the solutions on 0 to 2 pi, which is a unit circle. But on 11 through 24, you're finding what's all solutions. So we're going to figure out how do we get all the solutions. Now, I'm going to show you how to get 2 of them really easy. Now, let me look at 12 with you. All right, this one's real simple. You got cosine x equals square root of 3 over 2. Now, my trig function is already isolated right there. And you could probably tell me almost the correct answers here without me telling you how to do it. So all you do is you pick up a unit circle, you find, well, where is cosine of x equals square root of 3 over 2? Okay. In radians, pi over 6. Okay. I'm going to say x equals pi over 6. Now, where else though? Because usually you have 2 locations where you have a solution. 11 pi over 6. Okay. Now, here's the thing. That's 2 solutions, isn't it? All right. Most trig equations have 2 basic solutions. Now, but really and truly, there's an infinite amount of solutions. Because I want you to think about it. Visualize on like your unit circle. All right. If you're at pi over 6, what's another way to get to pi over 6 instead of just going right there? You go, what now? All the way around and go to pi over 6 with me. Okay. So if you went all the way around and went to pi over 6, you added 2 pi, didn't you? Okay. Now, you could go all the way around twice, couldn't you? So you could just keep adding 2 pi or subtracting 2 pi to get as many solutions as you could think of, couldn't you? Okay. So what we do to name all the solutions is we'll say plus 2 pi times n. A lot of times some people use k. Okay. Yes. Like your periodic identities. Okay. So I could do pi over 6, and then I could just keep adding multiples of 2 pi. So the n part tells me multiples of 2 pi. Now we do the same thing on the other one. So 11 pi over 6 plus 2 pi n on that one too. Okay, so get used to that 2 pi k or that 2 pi n. So when they want to know all the solutions, that's the way we're going to write it. Now, if we were only asked for the solutions between 0 and 2 pi, that would just be this and this. Okay, right, because it would only want just those two solutions. Okay, because adding the plus 2 pi n is going to, give them all. Okay, now let's look at a tangent one. Tangent is a little bit different, not too much. All right, let's look at number 14. It's got the tangent of x equals square root of 3. What's that? All right, so where's tangent of x square root of 3? Pi over 3. Okay. And where else would it be square root of 3? All right, reflect it over. I know it's kind of hard to see my unit circle, but now this one, that one right there would be at 2 pi over 3, it would be negative square root of 3, wouldn't it? So if you reflected it down, in the third quadrant, it would also be square root of 3 at 4 pi over 3. All right, now, you might be thinking plus 2 pi n. Not quite. Adjust that a little bit. Just pi n. What we say about tangent. The period of tangent function is just pi. Okay. Now, probably what's going to happen on the answer key is the answer key is probably going to only name this one. It doesn't hurt if you name both of them, but really just this one would be the solution. Just think about it. If you were at pi over 3 and you added just pi, it would be 4 pi over 3. And so like this solution this time with that on it covers the other solution. Okay, so that's why this one's only going to list this solution instead of both of them. Now, would it hurt if I listed more than one solution there? No. Okay, it's still fine if you just want to write them both. Okay, you don't really have to realize that. Now, let's look at one we're going to have to isolate a little bit. Let's look at number 20. Now, you'll figure this out fine too. All right, you got 2 sine x plus the square root of 3 equals 0. So when you solve a trig equation, it's not really about isolating x. It's more about isolating sine x or cosine x or tangent x. So what do I need to do to sort of just get that by itself right there? Yeah, subtract square root of 3. So then make it over here negative square root of 3. And divide by 2. That should be a familiar number there, right? So sine x equals negative square root of 3 over 2. So now let's look on our unit circle. All right, so where on our unit circle here is the sine square root of 3 over 2. Negative square root of 3 over 2. All right. 4 pi over, nope, that's not right. All right. Can't find it. All right, 5 pi over 3 and 4 pi over 3. Now, if my directions just said find answers between 0 and 2 pi, that would be it. Okay. All right, look. Where's the sign negative square root of 3 over 2? No. 5 pi over 6. That's where cosine is negative square root of 3 over 2. Okay. Where's the sine negative square root of 3 over 2? And right. You get it now? What you were doing, you were just looking at cosines and the sine. Okay. Now, there again, that would be solutions that would fall in between 0 and 2 pi. But the directions didn't say that. It said find them all. So it would be those two plus the multiples of 2 pi. So 2 pi n. All right, let's do one more like this, and then we're going to jump to those calculator problems. All right, let's look at number 24. You'll probably figure this out. It's got two cosines in it. Uh-oh. No big deal. So what are we going to do with the two cosines? Just add one to the other. Okay, so I would do this. And so just take a wild guess what you think that would be. 9 cosine theta. Now, here's one thing you need to kind of note about this. I can add the 7 and the 2 because the arguments are the same. If those arguments aren't the same, you couldn't do that. Now, and we'll just, what about that 9? Yeah. So we'll get this. All right, so now what? All right. And so that's going to give me -1. Okay, so now, where is my cosine -1? Okay, pi. And then that's it, isn't it? Just pi. Now, here's the thing. Over at -1, you remember at pi, that's called a quadrantal angle. A lot of times when you have a quadrantal angle, it's only going to be one solution. Okay. Now, it's really not just one solution. There's multiple solutions. That's pi. So again, if I was just asked between 0 and 2 pi, that would be it. But all the solutions would be pi plus 2 pi n. All right. Now, here's what I'm really worried about you. And you guys, a second period, I mean, they really, really struggle with this. Okay. So try to be really, really visual when we do these. Okay. They're calculator problems. And what I'm going to do here, I'm going to do problems like them. So maybe you can kind of look at them and follow them the best you can here. I'm going to do like 85. So instead of sine x equals, I'm going to do cosine x equals. So it'll be different. Okay, now I got 0.8246. And let's look at the directions on how they want me to solve it. All right, the directions say explicitly here to use a calculator to solve them. And they want you to do it to 4 decimal places. Now, what kind of answers do they want? Do they want all the answers? Only the ones that fall in between 0 and 2 pi. So like back here, if all they wanted was the ones that fell in between 0 and 2 pi, it just would have been the pi. Okay? Now, you're always going to get half credit on these problems because the calculator is going to give you an answer. That's all you got to do is throw it in the calculator. Okay? But the other answer is very, very difficult to get. Okay? And that's where you got to watch. Now, what will we punch in the calculator, you think, to get it? Because I certainly don't know where 0.2846 is on my unit circle. That's not one of my nice values. So how did we find, think about it, missing angles? How can I undo the cosine? Now you don't divide by cosine, you use something else, the inverse. Okay, so we do the inverse cosine. Now secant is the reciprocal. The inverse of cosine is inverse cosine. Inverse cosine on my calculator looks like what? Cosine of the -1. So all I have to do to get the answer, or one of the answers, is just do inverse cosine of this number. Now, I don't know if I'm in degrees or radians, and I need to be in radians. I can tell you whether or not I'm in, oh, that's in degrees. All right, let's go to radians. I wish we could do these in degrees. It would be nicer. All right, here we go. Inverse cosine of 0.8246. All right, so here's one of my solutions. And certainly that does fall in that range between 0 and 2 pi, so 0.6013. Now, here's the thing. Usually when we solve a trig equation between 0 and 2 pi, unless it's a quadrantal angle, it's probably going to have 2 solutions. And the problem is your calculator is only going to give you one of those. Okay, so for instance, let's look at like 6 or pi over 3, for instance. Okay, what's the cosine of pi over 3? A half. Now, so if I do inverse cosine of pi over 3, it's going to tell me, come on, it's going to tell me, oh, crap, this is, hang on, can't get anything right today. I did inverse cosine. All right, back up. Here we go. Inverse cosine of a half. All right. So where is cosine a half? We said pi over 3. Okay. Now that is the decimal equivalent of pi over 3. Now, isn't cosine pi over 3 1/2 somewhere else too? You get the point? And the calculator's not going to give me 2 answers there, is it? It's only going to give me 1. So what I have to do is find the other one by drawing a picture. Okay, now this is where people get lost. So I want you to tune in really, really good for me. Okay, y'all sit up and look. Now, what I'm going to do is I'm going to draw that first solution. Now, what I have to think about here is my unit circle in terms of decimals. So do 0, and what do I think about pi right there? 3.14, and half of pi is 1.57. If you didn't know that, you just punch pi divided by 2 in your calculator. This is 3 pi over 2 down there, which is going to be 4.71, and 2 pi is 6.28. Okay, we've done this before where we divided up the unit circle in terms of decimals. Now, where would 0.6 something lie? First quadrant, right? Probably not quite halfway. All right, so we got 0.6013, which is one of my solutions. Now, where else is cosine positive? In the fourth quadrant, right? So not only are we going to have the solution in the first quadrant, but we're going to have a solution in the fourth quadrant that we have to figure out. Okay, so I'm going to draw an angle, a reflected angle in the fourth quadrant, and we have to figure out what that is. Now, the way we have to figure out what it is to use a reference angle. So we're going to go back and use reference angles. Now, the reference angle for this one was just the same thing, wasn't it? Okay, so here's the idea. This angle is that much this way, isn't it? Okay, so that's 0.6013. Now, that's not in standard position though. So what I have to do, now that I got the reference angle, is find that angle in standard position, which would be this way with it. Okay, now, how would I figure out what the standard position would be around that way? From, right, now I'm not really going to say 6.28, but I'm going to use 2 pi. All right, now think about this, okay, because this is very visual. If I go all the way around here, that's 2 pi, okay? But if I go all the way and I stop right here, that's 2 pi minus that much, isn't it? Okay, so I'm going to punch in my calculator, 2 pi minus that. Now I got to get that number coming back up on my calculator. Hang on. So I'm going to inverse cosine of 0.8246. All right, so there's that 0.6 some number. So I'm going to say not 6.8, but 2 pi minus, yes. And then now instead of doing 0.6 something, we need to use what right there? Answer, because that's going to be accurate. Okay, so now that's going to give me this angle in standard position now. My other answer, 5.6819. All right, so I got that from the calculator, which nobody should miss. And then I found another one. So the calculator is going to find one. That's good. But you're going to have to be able to find the other one by using reference angles, and that's kind of difficult. All right, now talk to me. Did y'all get that a little bit? If you got it a little bit, that's still good. Okay, so most people in second period, they didn't get it at all the first time. Now, no, because it might not always be in the fourth quadrant. All right, so let's do one where cosine is a negative value. Okay, in fact, let's do this one, but let's make that 0.8246 negative. Okay. All right, so I'm kind of making this one up. So we got cosine of x equals, all right, let's say that it's negative 0.8246. All right, so let me punch in my calculator. Inverse cosine 0.8246. I didn't punch the negative. Which means I got to punch the whole thing in again. All right, there we go. So now we get x is about 2.5403. Okay, now that's one answer. There's got to be another answer somewhere, so we got to draw it. Now let's draw where that one is first and find the reference angle. Okay, so here we go. That's about 1.57. That's about 3.14. 4 point, is that right? 4.71. I hardly ever remember that one. This one's 6.28 or 0. Okay, now, where's 2.5 something going to be? In the second. Okay. So 2.5403, right there. Now, where else is cosine negative though? In the third quadrant. So there's also an answer in the third quadrant. So I got the answer in the second quadrant. I've got to figure out the answer in the third quadrant now. Okay. Now, the way that I'm going to find that answer is to use a reference angle. Now, the reference angle, remember, that's what the angle that forms with the acute angle that forms with the x-axis. Now, that would be this with it. Now, in our last problem, it was in the first quadrant. Remember what happens in the first quadrant? The reference angle is the same. All right. But if it's in the second quadrant, let's see if you guys can figure out what would the reference angle be right there. From pi. Okay, so think about it. All right, from here all the way around to here is pi, isn't it? So if I only go this far, it's just 2 point something. If I go this far, it's 3 point something. So all I have to do is subtract that from that, right? All right, so now my calculator, what am I actually going to punch in? Yeah, pi button. Okay. Then what? Answer, right. All right, so my reference angle there is about 0.6013. Now, talk to me. I know this is confusing for some of you. You're not saying anything, and I think you're confused. Do we need a better explanation or something that I can do here to? Right. Okay. Some people aren't visual; they just can't see that. But why are you saying pi minus that? I don't. It's hard for me to explain it to them. All right, down right there, because where else is cosine negative besides the second quadrant? No. No, we're not done yet. All we did was just find the reference angle. Now, the reference angle is going to be the same right here, isn't it? It would also be 0.6013. Now, think about it, okay? What I'm trying to find is this angle, right? So, right, watch it, from here to here is just pi. So it would be pi plus that much more. Does that make sense? All right. Let me erase that because that's kind of confusing. All right, so all I have to do is just do what? Pi plus what's on my calculator. Okay, so pi plus answer. All right, so we get the other one here, 3.7429. All right. All right, that's it. Let's try, let me do a tangent one with you now, okay? All right, we'll do, so we got tangent x equals -2. So I'm going to do -2. This one's very, very similar to number 89, okay? Now, all right, tell me what to get to on the calculator to get to the easy answer. Inverse tangent, -2. All right, now, there's a problem with that answer. All right, how come they can't be negative? What you got against negative numbers? You're like a negative racist. What's wrong with negative numbers? Look at the directions. It has to be in between 0 and 2 pi. And certainly a negative number would not be in between 0 and 2 pi. Okay, so you still have two solutions. It's just that one can't count because it's negative. Now let's think about it. What's a way we can get to the same spot but positive? Just add pi or 2 pi. Because tangent, you could add pi or 2 pi. It could be either way. Because 2 pi is just a multiple of pi, isn't it? Okay, so what do y'all want to add to it? You want to add pi or 2 pi? Just add pi? Okay, so let's take this number and let's add pi to it. All right, now there's a viable solution. Okay, so you got 2.0344. Now, there's still another one out there. Okay, now let's find it. So let's draw it out. All right, this is 1.57, 3.14, 4.71, 6.280. Now, where's 2 point something? Second quadrant, okay? Now, so how do I tell where another solution is going to be? Where is tangent negative? In the second and in the fourth. Okay. Now what's going to be is just the reflection across the origin. It's going to be straight across right there. Okay. Now, so how are we going to find that angle? Well, we need a reference angle. Okay. So let's find out here what that reference angle is. How could I find that reference angle? Pi minus that. Okay. So my calculator will do pi minus answer. Okay, so my reference angle is 1.1071. Now, so is that what this angle down here is? No, that would be the reference angle. So that would be this part of it, right? 1.1071. That's just the reference angle. Now we need it in standard position. Right? So think about it. All right. If I go all the way around, it's 2 pi. But if I stop right there, it would just be 2 pi minus that. Okay, so my calculator now will do 2 pi. Yeah, there's my other answer. Okay, yes, sure. All right, so let's go back. Did you understand the reference angle thing? Okay. Okay. All right. Now, so the reference angle down there is going to be the same. All right. Now, if I go, let me do this. All right. Now, if I go all the way around, that's 2 pi. Well, I don't want to go all the way around. I want to stop right there. So if because we're going from standard position. See, we're trying to measure the angle starting here. From standard position, you always start with a positive x-axis and go around counterclockwise. So if I go all the way around, it's 2 pi. But if we stop right here, we're stopping that much short of it. So we just say 2 pi minus that. That's that 5.1760. All right, let's do another one here. Let's see, what did I do so far? I've done a cosine. All right, let's do a sine problem, okay? And let's do one that's negative, because the negative ones are, actually you don't have a negative one. I'll make up one real quick, okay? All right, you do one with a fraction. It's really not that big of a deal if it's a fraction. Let's say sine x equals 1/3. Okay, now, if that would have said, let's make it positive, because you don't have to do any negative sign ones, okay? All right, so we got sine x equals 1/3. Now, if that was 1/2, this would be a nice unit circle problem. But 1/3 is not on my unit circle, okay? So now, we're going to do inverse sine of 1/3. And notice, you don't have to really use your fraction command. Just do it like that. Okay. So we get one solution here. It's 0.3398. All right. Now there's another solution out there that we got to figure out. Okay. So it's kind of like this. You know how I do this with you all the time? I say, I'll find this one, you find the other one. Okay, I found the one on the calculator. Now you find the other one. I know. Just inherently lazy, you know. I delegate the harder stuff to other people. Actually, I have a really tough time delegating. Right. Okay. So right. Okay. Now let's see what you guys just said. All right. Sine is positive in the first and second. Now we got the one in the first. Okay. Because that 0.3 something is going to lie in the first quadrant. All right. Here we go. That's 1.57. I'm going to stop right there because that's all I need. Now, so the other place where sine is positive is in the second quadrant. Okay, now, what's going to help me find that angle right there, though? Yeah, y'all got to it faster than I did, but that's fine. I was going to say this, the reference angle, which is the same, isn't it? So that would be the reference angle. Now, that's not what I'm looking for, though. I'm looking for the angle that's in standard position. So it's not quite to 3.14. It's this much short. So we subtract it from 3.14. So pi minus answer. All right. Yeah, there's my other answer. All right. Question. That's my other answer. So the calculator is going to give you one, but you got to find the other. And that's kind of difficult for some of you to do, to visualize. All right. Now, let's go over this real quick. Let's just do some housekeeping stuff about the end of the year, okay? Now, what I'm supposed to show you is not next week, but the week after, what I just kind of roughly thought about this morning. Hang on, let me make this. Yeah. Okay, so the ones I told you at the beginning there. Now, here again, this is more like this is the week after next, okay? Hang on, that wasn't what I was thinking about. That's next. Hang on. Yeah, on the back is the answers. No. All right, that's what I'm just to show you. If this closes out, my thing, I'm gonna be pissed. Never mind. All right. Now, this is week after next, which will be the 29th. Okay. You're gonna have your last test on that Monday, which will be most of what we're covering, like right now and next week. Okay. Now, Tuesday and Wednesday, we're basically going to review for the final. The final will basically be a 6 weeks test with a couple of easy questions from the 4th and 5th 6 weeks. Okay, I'll let you know what those are. So on Thursday, I'm going to get you to start your final. Now, I think you guys aren't really scheduled to start yours until Monday. Okay, so technically I can't really make you start that day, but I would just recommend to. Okay, so you're going to start it that day on Thursday. The senior slideshow is Friday, and Monday you're going to come in and you're going to finish it, because we know a 6 weeks test we usually can't get through one period. Now, if you want to do this, if you want to start it like second period on Thursday or first period on Thursday, so you could have it done by Thursday, that's fine. The slideshow doesn't start till 9 o'clock. You want to come in first period on Friday and try to finish it up so you can just be done. You can do that. Okay. Otherwise, you finish it on Monday. Now, juniors. That's what you're going to ask about. What? All right. Juniors, I cannot make you take the final with the seniors. However, I will stipulate this. If you don't take the final with the seniors, then I will move on with new material with you. Okay? The juniors. So, juniors, are we good with taking the final with the seniors? That's what I thought. All right. Y'all have a good weekend.